Today, we are going to be looking at Newton's 3 laws of motion as we launch this bottle rocket. Before we head outside with our bottle rocket, let's quickly cover the 3 laws of motion described by Sir Isaac Newton. Newton's first law: an object in motion will remain in motion, and an object at rest will remain at rest unless acted on by a force. Simply put, it's an object's tendency to keep doing what it's doing. Newton's second law says the force acting on an object is equal to the mass of the object times its acceleration. So the acceleration of an object, the change in direction or speed or both, depends on the mass of the object and the amount of force applied. Newton's third law: for every action there is an equal but opposite reaction. If you exert a force on an object, it is going to exert an equal amount of force back on you. Let's keep these in mind, as we will refer back to them as we problem solve with our rocket. Our launcher, powered by this bicycle pump, will fill our bottle rocket here with compressed air. When the bottle is released from the launcher, air is going to escape, hopefully launching it into the air. As the bottle pushes out the air pushes the bottle upwards. Newton's third law of motion. Increasing the thrust by adding more pressure to the bottle increases the acceleration. Newton's second law. If you're still here liking this video, you can show your support by hitting that like button, and most importantly, please subscribe. This is where we will be launching our rocket out in this field. We will be experimenting by changing variables to see how those changes affect our rocket's flight. In this first launch, we are going to have our rocket launch empty and see how far it will travel upwards. You will have noticed that adding a small amount of water causes the rocket to fly much farther. Why is that? Water is much heavier than air. It takes more force to throw water downward compared to air. In other words, the action force is greater when water is involved. And so the reaction force, the water pushing the bottle upward, has to be greater too. This is an illustration of Newton's second law. A bigger force causes a bigger acceleration. We see the bigger acceleration as a higher, longer flight. Let's add more water. We found out that adding water caused added acceleration. However, there's a tipping point. While more water is shooting out of the bottle, it is accelerating a now heavier rocket. From Newton's second law, we know that you need more force to accelerate a heavier object. So there's an ideal medium amount of water to create lots of thrust without adding too much weight. Give this activity a try. Your results will vary based on your design and the mass of the rocket you use. If you want to learn more science, you can check out this video next.
Did you get hit with that?
No. Safety first, kids.